fine, but I'm going to use some different variables. Okay, so I want to do the slope of the tangent line at A. And again, I want to interpret this as being the limit of the slope of the secant line through points that are approaching A. But instead of calling this B, instead of talking about my new point in terms of another letter, I'm going to instead talk about how far away is this point from A in the x direction. Okay? So I'm going to introduce a new variable, which I call h. And h is going to be the difference between the point, the other point on the secant line, and the fixed point A. Okay? So h is like the change in x. And so if this distance is h, and this distance is a, what would be the x-coordinate here? A plus h. So if this is the point A, f of A, then this is the point A plus h, f of A plus h. Yeah? Okay. And now I want to write the slope of the tangent line. Well, I'm going to start with the slope of the secant line. So this is going to be from the point A, f of A, to A plus h, f of A plus h. Okay? So then the slope of the secant line, written with these new, with this new notation, is the change in y over the change in x, which is y2, f of A plus h, minus y1, f of A, all over x2 minus x1. Yeah? Is that okay? Okay, great. And then, of course, you might notice, oh, there's an a minus a. Why don't we simplify the denominator here? So this slope of the secant line can be expressed as f of A plus h minus f of A all over h. Remember, this is just the change in y, and remember that's how we define h to be the change in x. Yeah. Okay. So that's how we're going to write the slope of the secant line. Now let's write the slope of the tangent line. Remember that the slope of the tangent line at A is the limit of the slope of the secant line. So this is going to be the limit of the slope of the secant line, which we computed, is f of A plus h minus f of A all over h. Now I've left my limit blank because formerly I had the limit as b goes to a. But now I've introduced some new notation and I've eliminated the b. So what is, if I'm going to take the slope of my tangent line, and I form the tangent line by looking at the limit of the secant line, as the second point gets closer and closer to my point A, f of A, then what's happening to my h.
Approaching 0.
It's going to 0. So this is, if we write our tangent, if I want to write our tangent line in this way, then we take the limit as h goes to 0 of f of a plus h minus f of a all over h. Good? All right. And then this here is one of our, basically the fundamental concept of differential calculus. We give this a special name. We call this the derivative. F prime of A. So this quantity here is what we're going to call F prime of A, which is the derivative of F at A. So the derivative F prime of A, this is the derivative of F at the point A. And so the derivative F prime at A, this is just a new notation to represent this difference quotient. This limit F prime of A is the limit as h goes to 0, f of a plus h minus f of a all over h, or in terms of our alternate, our first notation, this is the limit as b approaches a, f of b minus f of a over b minus a. Which is just the slope of the tangent line to f at a. Or the instantaneous rate of change of f at a. So now we have 5 different ways of talking about the same thing. Questions? Yes?
First definition
This is the definition of the derivative.
Okay.
Okay, so when you are asked to do something using the definition of the derivative, you use this guy or you use this guy. Okay. These are equivalent. We just saw these are just different ways of talking about the same thing in terms of this limit. Let's look at an example.